Schön, dass ihr alle da seid. Herzlich willkommen zu unserer ersten Session heute hier auf der Berlin Design Week. Das ist alles noch ein Experiment, für uns auch das erste Mal hier in Berlin auf der Design Week. Aber ja, ich freue mich, dass ihr da seid. Und es geht heute die nächsten 3 Stunden um Software-Design. Das machen wir seit fast 16 Jahren nun zusammen bei Wahnsinn Design, der Alex, der hier vorne sitzt, und ich. Und wir haben heute 3 kürzere Veranstaltungen für euch, und zwar einmal einen Vortrag zum Thema Software und Design, dann eine Design-Sprechstunde, wo wir einen Gast dabei haben, wo wir über ein Softwareprodukt sprechen und das Ganze unter die Lupe nehmen und Verbesserungspotenziale und Möglichkeiten aufzeigen. Und dann werden wir auch noch einen Podcast hier live aufzeichnen mit Publikum, und ihr könnt auch gerne Fragen stellen dazu und ja, probieren das Ganze mal vor Live-Publikum. Die Präsentation ist auf Englisch, wie ihr sehen könnt. Ich habe gerade einfach ganz natürlich auf Deutsch angefangen zu sprechen. Ich werde die Präsentation jetzt auch auf Englisch halten, sonst wird das ein totales Hin und Her mit den Worten. And I'm already sorry that I started in German, so now I know at least you understand English though, right? That's great, because I can only do German or English. I wouldn't want to try in French. Yeah. Today I will talk with you about why software needs design. First, a couple of words about me. I'm a designer for more than 20 years. As I said, I founded Wahnsinn Design with my colleague Alex over 15 years ago. I've been a lecturer in psychology for over 10 years in the past, and I'm a father of a brilliant daughter for more than 5 years now. And throughout the last 25 years, design and software have been my passion. And the question I want to answer today, or I want to try to answer today, is why does software need design? And I have a couple of answers to that. First, everything is designed. And I want to give you a moment, just look around you. Really, every object that you see, everything, the stools you're sitting on, the walls, this building, everything from the stage to this screen, really, nothing was just built. Someone saw a potential, an opportunity, and started the design process to think about what can I do to make that better? How can I help people sit? Yeah, and thought about how to make that stool practical, ergonomic, to make it comfortable to sit in. And the same sort of thoughts can apply to software as well, software that all of us use every day. So my friend and colleague Kalle even goes so far saying design is what makes us human, what differentiates us from the animals, because we not only live, we see these opportunities, we see potential or problems, and we start to think of solutions and embed them and try them and think about it again and review our work and try to refine it, try to make it better. So this started really as soon as we talk about humans. Really, really early on, humans started designing. We thought, okay, I need to crack open this nut or cut apart this piece of meat. And I have only my hands or my feet or my teeth, right? And so maybe I can use this rock and start with a rock, but the rock is blunt, I need to sharpen it. Again, I'm planning, I'm trying, I see, okay, the cutting is better, it works better, so now I have a tool. And by doing this process over and over and over again through the years and thousands of years, thousands of repetitions, more or less a design process, we end up what we use today, a knife for that purpose, or obviously this tool differentiated in different shapes. For example, a hammer. It was one tool, now it's 2 optimized tools. But this obviously is the design process in action. I plan, I perform some change, and I review it and I refine that. And the same goes for software as well. The earliest software, the earliest computers, obviously these are not, I'm not starting at the earliest machines with cards and physical programming. The earliest personal computer, let's say, looked pretty much comparable to the rock in our current understanding of how software can look. Yeah? So this was 1981, the DOS operating system in IBM PCs. And only 3 years later, the design process has moved on and the interface changed. And this is an example of an interface of the first Macintosh, built in 1984, promoted with the now world-renowned advertising that you probably remember. And it looked completely different. There was more refinement being done, right? So we went from the line-based text input to graphical user interfaces. This was the first computer, so the first software platform with a mouse, with a mouse pointer, with the indirect operation, not only with a keyboard, but with a mouse. And already, only 3 years after this first IBM PC, we have this. And this actually blows my mind today, because this is 1984, so this is 40 years ago. We had rounded buttons, or what we now would even say, this is obviously a button. But no one knew what a button was at that time. This is the first graphical interface, and it has a button that we now, even now, recognize 40 years later. Why? Because it has these rounded corners. It's not just a box with some text in it, but it's a button. So probably I can click it. Today, obviously, we would say, what is a click? I can touch it, right? But it won't work, obviously. But why was that? This was because of Steve Jobs, and Steve Jobs said, rectangles with rounded corners are everywhere. There's a quick little story about that. So the first engineer who implemented this interface that I showed you before had rectangular buttons. And Steve said, can we make those corners rounded? And he said, well, this is really, really hard. You know, there's math involved, and the computers were really slow, so this is really hard to do. Why should I do that? And Steve said, look around you. We have rounded rectangles everywhere. You know, everything that was being designed was already designed by rounded rectangles. Obviously, the roundings can be big, like for example in these chunky speakers. Not in 1984, but there were speakers with rounded rect. Sometimes the corners are smaller, like in this example here, but it's still rounded. So everything that we do is rounded. Why is that? Because really, really sharp corners are dangerous. They can hurt. Yeah? You can hurt yourself. And Steve didn't want users to feel like they can hurt themselves using the interface. He wanted the interface to feel less threatening, because he knew it's new, it's threatening in and of itself. You need to learn it. So I want rounded buttons. So nowadays we recognize this directly. This could be something else. Obviously there is a label button and make it easier, but it can be something else. It doesn't have to be a button. But the left one, it's smooth on the corners. If it was a physical object, I wouldn't be afraid to touch it. It's nicer to touch. So that's what we recognize today, and most systems use that. Obviously not all systems use that. Still, even after 1984, a lot of systems still relied on buttons with sharp edges. But even Microsoft, if you go to the Microsoft.com website today, they changed to rounded rectangles, but only just recently, a couple of years ago actually. So design process goes from the big ideas. What is a tool? How can I evolve that? Even to the smallest and tiniest detail, there is also evolutionary process. And sometimes people get it really right, and then we can continue on doing it and recognizing it as such, and sometimes we need to refine further on. So from this first part, what do we take away? Every man-made thing is designed, whether we call ourselves such or not. We design things. Everyone is a designer, and while we are designing, better be good at it, right? So let's try to make it better, especially in software, what I will talk to you about now. So in the second part, is the special thing about software is that it can be really anything. With physical objects, like the stone, or like the stools you're sitting on, or like this chair, it's a bit different. it's really, really hard to start to design this, because you need to prototype, you need your time, you need the materials, you need the tools to build that, and then you have the physical objects, and here it is, and it takes more time. It's a higher hurdle you have to overcome. And also, because it takes so much time, obviously time mostly equals either your time or someone else's time. You need the money for the resources. So there's a higher risk involved if you're wrong. If you're wrong, you need to try again. You need new materials, more time, and again and again and again. So physical design has a higher risk. But when you're done, you're finished. This chair is now ready to be set upon, and it can live its life. Obviously, maybe you need to repair it. If you love it, maybe it needs some kind of fresh coat of paint once in a while. But it's finished more or less as an object. On the one hand, today, and I mean really to 2024 and going on, it's really easy to start software. Everyone, anyone has access to computers nowadays or to smartphones. You can start developing software or building software from your phone in minutes. You get explanations, you get help, you get services that you can use. It can get really easy. Even someone without experience can sit down and maybe after an hour, without any experience at all, has the potential to have a website online somewhere. Or even a small service, not only a website, but something that people can use. So it's really easy to start. And because it's easy to start, and it's because it's so quick, it's less risk that you're wrong. So you can put something out there, and the risk is not high because you can redo it and retry, and it's always not a lot of work. So in effect is that it's actually never done, because when is anyone ever really satisfied with something, right? You see it, you came to this new point, you look back and say, okay, maybe I can do it even better because you learned some more. So software has this problem. It's not like a chair where you have to put it somewhere and now people can sit in it. You can give software for someone to use, but you can always you can update it. You can make it better, and you can see the potential and make it better. So completely different areas, but still we say that it's the same in many ways. I don't know why this is happening. Sorry. Brilliant. There we are. But is it actually such a low risk? Because software can be anything. Software can also be something like this. So this is a bit of older piece of software, but we still see software like this. This is just one example of many in use today. Maybe you haven't seen that in person, but there are many interfaces where we sit in front of and feel like it looks like this. And there's a high risk involved, because no one can use that, right? It's overwhelming. Because it's never done, and it's so easy to do, we can just add and retry. And most of the time we add something more, and then we are there, and then we are there. And then we come to this stage where actually we no longer have a chair that anyone can sit in and recognize as a chair, but something that people cannot use, can no longer achieve their actual goals with. Why is that? Because of technical debt, for example. This is a term we use in software development. So when I build something and I rebuild it and I rebuild it, that's not a clean process. I don't throw away everything that I've built before. I attach, I add on top. Yeah? I'm building these pyramids. And sometimes actually what is used from the code is these new things on top, and there's a lot of stuff in the background that I'm no longer maintaining. I don't know what it's actually doing, so it gets convoluted quickly. And adding something new or changing course becomes even harder over time. So it gets more hard to change. Easy to start, but hard to change. The second piece is processes. Software can only be as good as the processes behind. That's especially true in corporate contexts. So if I have a corporation which says communication goes this way, if you want to achieve this, you need the check or the okay from your colleague over there, and only when you have that you can proceed. So the processes can be strange. That's why the software is strange. And also habit. Software is used for so many years now that people get used to the way it behaves, especially, again, in big corporations, obviously normal users as well. We get used to how it is, and change then proposes its own danger to us as users, because I know where to click. Even in this specific interface, there are probably humans who used that and knew how to use it. And it's a bit like, I always say it's like Harry Potter, you know. I have this wizardry, I need to click over there, and then I need to go here, and then Wingardium Leviosa, and then it works, right? And now I change this, and I put these things over there, and I hide this, and I put this away, and now the user is confused, because they no longer know how to achieve what they want to achieve. So change. There is actually risk involved in every step. In every adding something new, you risk being you lose flexibility in the future. So, wrapping that up, it's easy to get going, but it's hard to get right, and it's getting increasingly harder to get right if the only thing you're doing is building upon building upon building. Software can be anything, but at the same time it cannot be everything. It can just get too convoluted, too big, too confusing. And that's why we need design, because design can help, because as a discipline we have developed in other fields, not in software, but building chairs, for example, or building buildings, for example. We developed a process to help prevent that. And we do that especially by doing two things. One is design tries to get an understanding for what the actual need is. Right? We don't look at the object, we look at the thing that the people want to do. The chair is not only there as an object, it's there because people want to use it. We want to sit down, we want to feel carried by it in the way that it's not hurting anywhere, right? And we want to rest. And that's why the chair as an object was developed. We understand why rest is needed, and our understanding of that changes. So we now know sitting too long is not so good, so maybe we need to design other chairs which look different, which make resting in a different state better, so it's better for our health, for example. So understanding on the one hand, thinking about the user, thinking about people, and focus. And focus is if I understand the user, user-centered design is the term there. If I understand them, I can focus on what helps them the most. And focus does not mean saying yes to this and then to this and adding, but actually mostly it means saying no. No, we don't use that. We don't need that. So saying no a lot is... And having reasons for it, because we always understand the actual need, is why we can make software better. So bringing those two things together, so that everything is designed, even software as well, and that we as designers can help, we try to find a way to more or less codify that, to help ourselves to make that into an easy-to-follow process. And that we reached this process that we call design-driven evolution. And this consists mainly of 4 parts again. Design-driven evolution is just 4 parts, which, in our experience, what we learned from designing software over the last 15 years. And we have these 4 rules for that. The first rule is people do not know what they want. Alex and me, we actually met in our studies. We studied psychology, we didn't study design. And in psychology, you quickly learn if you ask someone what they think of something or why they did something, they can answer you, always, but this will probably not be the truth. Yeah, that's the fundamentaler Attributionsfehler. Yeah? Sorry, I don't know the English word for that. So we always have a reason. If you ask someone, people always have reasons for what they do. But while they're doing, actually, they're maybe not aware of these reasons. Maybe the reasons are completely different than the ones we think we have. So we can actually not go around and just asking people What do you want? What do you need? We need some other way to find that out. So when we go to someone who needs software or thinks they need software, we don't ask what. We actually ask why. So what is your goal? Not what do you need, what do you want, but why do you want it? And we ask that a lot. We ask it so many times that it's actually like we get sick of it, of asking it. The clients or our partners sometimes do get sick of it, but asking once is not enough. It's like, I think it's general knowledge by now that in active listening, you don't just ask once and then you go away. Then you're not an active listener. If you want to get to a point, to the core of the apple, you need to ask and ask again. So why is this? Why is that? From the big picture to the little detail. Why are you actually doing what you're doing? If you're talking to a corporation, why do you exist? What is your purpose? Okay, now I said what. But yeah, it's actually a why question. So, and then why do you do this and this smaller thing and this smaller thing? And you go ever deeper. There is no edge case in design. There is no thing too small that you can ask, why are you doing that? Because always, if the answer is because of a habit, because of existing processes, and because we've always done it like this, or we actually don't really know why. Why are we doing this? I don't, these are the best answers. This is so brilliant because then we can, okay, put it away. We can say no. We don't need that. We don't need that switch. We don't need that button. So these whys are really important. The second rule is everyone has their own mental model of the world. I am talking to you now, and I hope I try to help you understand my point of view here, but every one of you has different ideas at the moment about what I'm talking about, or maybe what they had for lunch, or maybe what they will have for dinner, or about any other topics. So, and also about what I'm talking about now. You have your own experience, you have your own views, and this is brilliant. That's why we're all different, and we love that. But so we cannot expect that just talking about something that we all understand each other. For example, imagine a beautiful piece of music. I'll give you a minute. No, I don't. But I don't know what you're thinking of now, and it's really hard to imagine beautiful music. Not everyone can now go inside their mind palace and think of Bach or Hozier or whoever, and now hear beautiful music. But I can do this. So that's how you get time passed in a talk. Only 5 more minutes. I like that. I think that's beautiful music. But of course, I don't need to tell you to think about it, but I can just show you. Yeah? And I think showing something, not talking about it, and I'm now talking about it, but I'm also showing you things. So showing something is the biggest power that a designer has. We can, sometimes in seconds, sometimes in minutes, sometimes in days, but we can talk about something really quickly and directly start showing it. What we in a physical design, it would be prototyping or sketching something, but we can actually show something, and something happens. Because when you start with this blank page and say, okay, we have this solution here, this software is so beautiful, it's working seamlessly, and it's really easy. And everyone, you have a meeting with 5 people and talk about that, and everyone will understand you and say, yeah, this is so great, and everyone has a different picture in their mind. No one thinks the same that you think. But as soon as you start the most rudimentary thing like this, drawing down this first version of a wireframe, that's what we're calling laying out, or layout in print, it would be the word, right, in print design. The moment you start doing this, you get direct, visceral reactions of people. They say, no, I thought the same thing, or no, I'm thinking completely differently. So the moment you start showing, you get opinions, you get thoughts, and you get specific feedback. And you can make it in any tool you want. It can be high res, low res, it doesn't matter. But showing directly is so enabling in the design process. And then you can start. You sketch, you play around, you say, no, I want it to be like that, or I want it to be different, or actually I want it to be mobile, or something like that, yeah? But as soon as you start doing this, people can react to it and see it and feel it. So we had great results by going into specific designs, into concrete designs directly. He wants, what do you want from me? Yeah, exactly. Why? But he's not responding. I don't know why. I return to that experimentation in a second. But so the third rule for us is you don't know what you want when you start. Design is actually a process of learning what you want to achieve. Either the people who want you to do it or yourself. You don't know when you start out. So. There's actually something at work when you start with this blank page, or when you have this idea and you start communicating about it, and you build something out of it. Yeah. So this cute little fox out of this paper, and then you talk about it, and then you say, no, okay, that was not the right thing. Scratch that. I actually want a bird. Right? No, not a small bird. I want something that flies. Yeah, but no, it should actually look a bit different. Yeah. So this process of repetition, of creating something, reviewing it, and repeating this process helps you on the path to learn what you're actually trying to achieve. What is the better solution? Obviously, there are time constraints. There is always budget constraints. How many times you can do it? But the faster. Remember rule 2, the faster you go into showing, the more of these cycles you can repeat. And what you do is not only reviewing, but what you do is you edit. You find the things that work in this, for example, the bird, but I actually wanted something that can fly, so maybe there are other solutions that can fly, so there's editing. And what you also have to do is destroy. You have to let go of the fear that you created something wrong. Because creating something wrong can be the starting point. That's brilliant. If you learned that you're wrong, that's in psychology, if I made a study and I know that I failed the study, that's the best result that I can get, because I can probably guarantee that I'm right, that I'm wrong. Okay, so being wrong, you learn so much more than being right, because it could be just a coincidence or a lucky shot. So being wrong, destroying that, and rebuilding is quite powerful. And the fourth rule is only real tests offer real insight. So we need to take that trying and trying again a bit further. We don't not only do that on paper or in our design tools, but with the stuff the software is built from. Because software is so easy to start, as we said, it's not like building a house where you built the house and said, nah, that's not what I wanted, put it down, build up a new house. Way too much risk, right? So, but with software, we can really quickly start implementing, try what we built ourselves, say, not the right stuff, we maybe destroy it, build it again. If that takes days, that's actually feasible. If it takes a year, not possible, so we need to be really quick. But the best thing that we can do to evaluate that is actually observing and not trying ourselves. Trying ourselves is great, but observing people use the software. Ideally, while they are not noticing that, in science also you always want to ask or find out things while people are not aware that you're observing them, but that's not so it's not so easy. But observing real users doing what they do is quite powerful. They don't even need to tell you what they're doing. You just need to look, really. If you sit beside them and they are using your software, you will, in half a minute, you will have 3 things that you can do better. Always. And they maybe cannot even tell you, because we are so used to software being bad that we cope. Yeah, we use it and say, didn't work, try again. Yeah, click, click, bip, bip, bip. No? Okay, I will cope, but that's bad, that shouldn't happen. So if the designer of that software would now see me, he would say, why did this happen? I need to fix that. And he wouldn't maybe in his controlled environment, but in the actual environment it would work. But one thing we need to remember with this, observation is mostly done nowadays in software indirectly by tracking, by something like an analytics software like Google Analytics, or tracking statistics. And I love this quote by Maria Lorenz Buckelberg: statistics don't tell you what to do, they only show you what you're doing. This is just a starting point. This is an inspiration of what you can do. It's not a limiting factor of what you can do, but it shows you, okay, there's maybe something wrong or amiss in what we are actually trying to achieve, but we can go from there and build upon that and not say, okay, this is working, we need to build that out. That's not a one-on-one correlation, not a direct direction. So if you follow these 4 rules, you can start with some sketches, but achieve maybe the actual goal that you try to reach, and your idea, your software can fly. 4 rules: ask why a lot, show, don't tell, iterate and reduce, ideally, say no, right? Not build upon build, but actually come closer to the things you want to achieve, reduce it, and test for real with real people. As I said, we wanted to make it easy. It's not really rocket science, right? It's just letting go of your fear of making something wrong and just get in there and try to do that. And if you remember this one thing, is that using the software itself is not important. The people that use the software, their needs are important. So when you think about that, you get a sense of, it's not using the software, giving people software that they can use all day, every day for a lot of time, but actually software that goes out of its way to make it quick to achieve what you want and then put it away and have that goal achieved in the quickest way. You don't want these chairs to follow you around the whole day and talk to you, right? You just want to go there, sit, say thank you, and then you go your way. And this same perspective can be used for software as well, but not really actually only for software. Really pretty much everything that we design. The object itself, it's really important to us, but it's not the important thing for the user. They are expecting a specific goal to reach it, and that's the important part. So, I talked about a few things, so maybe if you want to remember some more, you have a few of these ideas. If you want, I can also send you these slides so you can have another look or remember that. And with that, thank you for being here.